Hey pre-calc students, I hope you guys are doing well. This is our first video here with our distance learning, and it's going to be a little bit different. Today I'm not just going to make a video lesson where we do notes and things like that. You'll get a lot of that here during our distance learning, but what I would have typically done next if we were together is work on a very fun problem dealing with trigonometry and a bicycle. And I just really didn't want to miss out on this opportunity because it's a good one. It gets us thinking, and then it'll lead us into some of the examples and problems that you're going to be working on. So this is going to be a little bit different. Typically, if we're in class, what would happen is I would put up on the board my video from YouTube, and you would watch the video, you would receive some instruction, and then the screen would say pause. Okay, and that's where in class I would pause it, and I would let you guys work on it for a little bit in the appropriate amount of time, and then we would hit play again, watch to the next one till it hit pause, and then we'd pause. I'd let you guys work, and then what would happen is we'd have a little group discussion, and I would be at the board, and we'd work it all so that we'd all could agree or come to an agreement on what the problem should look like. So what's going to happen here is I'm going to switch from this to the YouTube video. And you're going to watch the first section. It's going to hit pause, hit pause. The first pause should be pretty short. It's going to take you like 30 seconds to probably do what I'm asking you to do. Then you'll hit play. Watch again. I'm going to give you a little bit more of a visual on what I'm going to ask you to do. Pause. Again, that's going to be pretty short again. Again, that should only be like 30 seconds. Hit play. Now in the next segment, there's going to be a lot more detail. And I'm going to get a lot more specific on what I'm asking you to do. The first two, I'm a little bit vague just to get you thinking about what's happening as the bike is moving. But when we get to that third pause, this is where I really want you to stop, and I want you to put some serious effort into doing what I'm asking you to do. Now, when you hit play, it's going to come back, and it's going to be me working on the whiteboard and showing you exactly what I came up with. So as you do this, and I don't expect every student is going to be able to necessarily figure this out on their own, but you need to put serious thought into it. Work with it, draw sketches, and when you think you've got it, go ahead and hit play and see if you and I agree. Or if you've worked on it to enough where you reach a level of frustration where you're not sure where to go with it, then go ahead and hit play. But I would expect that this might take like 5 minutes of time on your own before you come back and play. Then, like I said, we'll come back, I'll walk you through it, and then we're probably going to reach the end of the video. We've got about a 15-minute time limit on each video that I'm making. I'm trying to keep it to that. So we'll wrap up that, and then you're going to have to go to the next video to continue with this bike problem. So with that, let's turn it over to the YouTube video. Enjoy.
Oh, hey guys, how's it going? So I was just out for a nice bike ride here, a beautiful day, and I couldn't help but think as I was biking and I was watching my front wheel spin around and around that, you know, spinning circles usually have something to do with trigonometry. And I couldn't help but get caught on just a part of my front wheel here. So what I would like you to do is there's a spot here where you pump in the air. Okay, technical term for this is a thingamajigger. Okay, and I'm kind of wondering what happens to that. What path does that take as I pedal my bicycle? So I want you to think about what that path might look like. Okay, we're going to stop the video here, and you're going to make a sketch of what you think it would look like. All right, so have you had a chance to think about what that might look like, okay, as it spins round and round? Well, to give you a little bit better picture of what this looks like, okay, I've got some chalk here. Well, there we go. Okay, and I'm gonna chalk this up. There we go. And let's take a look at what this looks like here and follow the path as I move this bike. All right, so let's get some details here. Got my tape measure. Okay, one of the pieces of information that you need to know is what is the radius to the outer edge of the tire. So, okay, if we're going to measure that, we've got 14 inches. Read them nice and clear. 14 inches. The other piece of information that we are going to need is the radius to the thingamajigger. So we're going to go right to the end of the cap here, and I'm going to measure that. And that is, yep, just confirming 3 inches shorter. So we've got 11 inches. So the first thing I want you to do now, okay, you've got an idea of what the graph looks like. Let's start to get a lot more specific. I want you to write a function that gives the height of the cap, okay, as the angle changes. So y-axis needs to be height, x-axis needs to be theta. You have the information that you need.
Right. So, in the first couple, I just wanted you to sketch a rough guess as to what that path looks like, and I gave you a lot more details here right before this last pause. And one of the main details is we have to figure out what our axes are going to be here. So let's set this up where I'm going to have my x-axis. I'm going to draw my y-axis. And we need to label these. And for this one, okay, we're labeling the x-axis as theta. And that will be measured in radians. Our y-axis is going to be our height. And we're going to measure that, or graph that, in inches. So I gave you some details, and I think it's going to be best, and I'm hoping that you guys did this at home, is that you sketched a little bit of the wheel here to mark and show what's going on. So let me get some circles out here. Oh, light turn on. There we go. All right, so let's say that's the outer edge of the wheel. Okay. And we know that this has a radius of 14 inches. But then we've got that thingamajigger, and that's 3 inches in from the outside, or 11 inches. And as that bike, as that wheel is going to spin, that thingamajigger will also follow the path of a circle. So I'm going to draw another circle. Let's see here. Hopefully this, nope, goes from the inside. Let me try that again. Let's do this. There we go. That looks lovely. Not quite perfect, but it'll work. And this has a radius of 11 inches. Okay. So now it's going to come to graphing time. And if we are graphing this x-axis as radians here. So I drew this so the thingamajigger is starting at the top. It's going to start at the top, and we have to know what its period is. Where is it going to be back, or when is it going to be back to where it started? And because I picked this x-axis to be theta, which is in radians, we know the period. It's going to be back in how many radians? 2 pi. So our period is 2 pi. So we're not going to do any stretching and so on. All right, so now let's try to sketch this, and then we'll be able to write the function. Right now, if we say that this is at 0. That means that's the ground. So let's draw the ground into our diagram here. Missed it a little bit underneath. Let's try that again. It's a little bit better. Okay. I'm starting at the very top here. And how far above the ground is that thingamajigger right now? We know it's 11 inches from the center of the wheel. But how far is the center of the wheel from the ground? What is that total height? And if I were to sketch this distance in right here, we know this, don't we? We know that that's 14 inches. Okay. So we can see that the total height to the top is 25 inches. So on my graph, I'm going to put the top at 25. Okay. Now, where's the bottom? Okay. As this thingamajigger goes around, what's the closest it gets to the ground? Well, the closest that it gets to the ground is going to be right there. So now this is 11 inches. And how far off the ground are we here? Okay, just 3 inches. So I'm going to put my 3 inches as my bottom. And then it's going to rotate around. So this is going to oscillate up and down. Okay, where's the midline? Okay, well, it should be pretty clear to us here that the midline is going to be 14, right? It's going from 11 above to 11 below, and it's circling around the center of the wheel, which is 14 inches. So I'm going to put 14 right there in the middle. I'm going to use a dashed line for that midline. Just like that. So the thingamajigger is going to start at the top at 25 inches. It needs to return back to the top in a period of 2 pi. So I'll just put 2 pi right there. We know that we need to be back at 2 pi radians. Where is it going to bottom out at at a height of 3 inches? Well, that would happen halfway through the period at pi radians. Okay. Where is it going to be at the midline? At pi over 2 radians. Okay. And then again at 3 pi over 2 radians. Ooh, we're going to try that again. All right, it's not a great sketch, but that's roughly what it's going to look like. So now can we write that function? I'm going to call my function h of theta, the height given at time theta. And what do we have here? Well, taking a look, because we started at the top, and we didn't have to. We could have started at the midline. We could have started at the bottom. If we started at the midline, it would have been a sine function. Because we're starting at the top, we should recognize that this is going to be cosine. If I started somewhere else, like at the bottom, I could do cosine, and then I could reflect it. There's a lot of things that we can do, right? There's infinitely many different functions that we can write that would all match up graphically. So I'm going to use cosine. What's the amplitude of my cosine function? It's 11, isn't it? Okay. My period is 2 pi. I don't have to do any stretching or condensing, so I'm just going to say 11 times the cosine of theta. Now, if that was it, it would be oscillating around the x-axis as our midline. But we have to take this graph and we have to move it up 14. So I've got a plus 14 right there. That is our height function based on the angle. Let's head over to Desmos and let's just graph that. I'm going to do h of theta, and we're going to type in 11 cosine of theta plus 14. Let's zoom out here. So it starts at angle 0 with a height of 25. It's back there at 2 pi radians later. So that's going to wrap up this video. Please go on to the next one to continue our bicycle problem here.